Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at compound interest. So compound interest is when you invest a certain amount of money and that amount increases by a certain percentage each year. So because it's increasing by the same percent each year, the actual amount you have increases at an increasing rate. Compound interest is an example of exponential growth, and that's why we're going to use the same formula we've used for exponential growth. So just remember, for growth, when the amount is getting bigger, we have a plus here. So other than that, the letters all mean the same thing. P means principal, the amount you start with. R is the rate per period. N is the number of periods, number of increases. And of course, we're calculating A, the amount of money you have. So if I invest $100,000 at 4.8% per annum, how much will I have in 20 years if interest is compounded annually? Well, we're just going to use the formula A equals P. So P this time is 100,000. Multiplied by 1 plus 4.8 is the rate over 100, and then we raise to the power of 20. This is just saying we have 100,000 and the amount is increasing by 4.8% year on year. So after 20 years, we'll have this amount. So you can just put that straight on your calculator. You get $255,402.80. So for money, always round to 2 decimal places. So this is pretty much the same as what you've been doing. But when we're doing compound interest, we have to change things if it's not compounded annually. So all banks would give you the interest rate per year. But if it's not compounded each year, if it's compounded at a different frequency, we need to change the rate. So the rate's 4.8% per annum or per year. So per month, it will be 4.8 divided by 12, which is 0.4%. That's the rate per month. Now we also need to change N, because if you compound monthly for 20 years, there won't be 20 compounds. The number of increases will be 12 per year times 20, which is 240. So when we go and use our formula, it will be A equals P. P is still 100,000, but we have to use R as 0.4. It's still over 100, but this time N, the number of compounds, is 240. So putting that in our calculator, we have $260,670.01. So similarly, if it was compounded daily, we're going to need to change R and N first. So the rate is 4.8% per year, but per day, it'll be 4.8 over 365. We can assume 365 days in a year, don't worry about leap years. So what will be N? N, the number of compounds, will just be 20 times 365. There's 365 compounds each year for 20 years. So we're still using our exponential growth formula. It's just the different values for R and N. So the amount, well, the principal is going to be the same at 100,000. So it'll be 1 plus, and we'll just put R like this because 4.8 over 365 is not a nice decimal at all. Divide that by 100, and we're going to raise that to the power of 20 times 365, which is actually 7,300. So putting that in our calculator, we should get $261,153.16. So note, if you keep everything constant, the principal, the rate per year, and the time, the more frequently the compounds, the more money you have. You can see we had a little more money when it was compounded daily than monthly, and we had more money when it was compounded monthly than annually, and that is always the case. So the more frequently you compound, compound, the more money you will have. But it does reach a limit. It's not like if we start at $100,000, if we compound it enough, we're going to end up with $1 million. It's just a little bit more of a difference the more frequently you compound. All right, now we're going to look at questions where we're using this formula in compound interest to find P and R. So how much must I invest for my investment to be worth $8,000 in 5 years' time if interest is 3% per annum and it's compounded quarterly? So hopefully you can see from this, we are asked to find P because that's the amount of money we originally invest. So to find P or to find any of these letters, we just substitute in everything that we know. So we're told that A, the amount I want to have is 8,000. So I replace A with 8,000. So we're told that R is 3%, but it's compounded quarterly. So the number I'm going to substitute for R isn't 3, it's actually 3 divided by 4, which is 0.75. So we had to divide 3% per annum by 4 because there are 4 quarters in a year. It's 0.75% per quarter. So now we are going to substitute N. N is the number of compounds. If it's compounded quarterly, so 4 times a year for 5 years, the total number of compounds will be 20. We now have an equation that has only one unknown, so we can solve it. Note that this here, it will not be a nice number, but it is a number nonetheless. It'll be a really annoying decimal, but it's still a number. So when you have 8,000 equals P times something, you just divide each side by that something to get P by itself. So this time I'm going to give it to the nearest dollar. Putting that straight on our calculator, we get $6,890. That's to the nearest dollar. So this is what I would need to start with so that if it's compounded quarterly, for 5 years at 3% per annum, I will end up with 8,000 at the end of the 5 years. So let's now look at a question which we're finding R. So we're asked to calculate the interest rate required. So that is R. That's how I know I'm finding R. We're told the investment of $10,000 is to double in 8 years' time. Interest is compounded annually. So let's just go to our equation and substitute in everything that we know. So we know A and P straight off. So we're told that P is $10,000. Now, if I want my investment to double, I want A to be double that. I want A to be $20,000. If it's compounded annually for 8 years, there will be 8 compounds in total, 8 sort of recalculations of the amount that we have. So now we have a formula, an equation that has just one unknown, so we can solve that. So 20,000 divided 10,000 is just 2. So I've got 2 equals 1 plus R over 100 to the power of 8. So this looks like quite a tough one to solve, but we know how to do this. What we want to do is undo this power of 8. So what we actually do is take the 8th root of both sides. So we take the 8th root of 2, and then we take the 8th root of this, because taking the 8th root of something to the power of 8, they cancel out. So I'm just left with 1 plus R over 100 on the right-hand side. Now, I'm not going to go and say what 8 root 2 is because it's not a nice number at all. It's irrational. So it's probably easiest just to leave it as the 8th root of 2. So now I want to get R by itself. Well, R has been divided by 100 and 1 has been added. So what I'm going to do is take the 8th root of 2 and minus 1. I subtract 1 from both sides and I'm left with R over 100. So now to get R by itself, the way I undo dividing 100 is times 100. So I times the left-hand side by 100 and I times the right-hand side by 100. But of course, dividing 100 and timesing 100 undo each other. So I've just got R equals 100 times the 8th root of 2 minus 1. I can put this straight on my calculator. So if I put this on my calculator like that, I get about 9.05, and that of course is a percent because it was compounded annually. That's going to be the rate per year or per annum. Another good thing about using 8th root of 2 rather than writing it as a decimal is my answer here will be exact. If I round this number at this step, my final answer won't be accurate. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.